Hi everyone, today we're going to be talking about Mario Kart and trigonometry. So for our first problem here, we're going to be using trig ratios and special angles done by Matei. So there's 3 players and essentially you want to figure out how many laps they've completed given them being at certain angles. So just for our steps, we're just going to convert each angle to radians. Then you're just going to determine where each player is in the quadrants. And then we're just going to evaluate and compare to find the placement of them. Just kind of using trig ratios and special angle measurements. And then at the end, you will get everything. So for our second problem here, we want to figure out the new player placement and where they are in radians. So for this, you're just going to convert the laps back to radians, and then you're just going to adjust each player's position based on whatever happened to them. And then we have just the unit circle. This is just a little brief explanation of it broken down. So the angle can just be the angle can be seen as where the placements of the characters are. The coordinates can be their position on the track as coordinates. The trig functions can be used to explain their movement, hence the cosine and sine functions. And then the quadrants just can be categorized into 4 quadrants, which correspond to the unit circle. Okay, and then Ethan created our trigonometric modeling problem. And essentially in this problem, you're just going to want to find the distance from the center of the track to the apex of the turn. You're going to find the angle of elevation from Mario to the apex of the turn. And then you're going to find the angle of approach from Mario's kart to the apex of the turn once again. Sorry, the approach, not elevation. And then you should get your answer. So for this, we're going to be proving trig identities, and we can relate the trig identity to a drift. And we're going to prove cos square x plus sine square x equals 1. And essentially for this, you're just going to set up the scene. You can see what x and v equal. And then for step 2, you're just going to decompose the equation, essentially breaking it down. And then moving to step 3, you're just going to use Pythagorean theorem, and step 4 you're just going to substitute and simplify, and then step 5 gives you the answer.
And then this is just our answer related back to Mario Kart. So essentially a perfect drift maximizes cosine x while minimizing the sine x to get the closest value to 1.
And then we're just going to follow the same exact steps for another problem, just so we can get the steps and the correlations down pat. So as we can see in problem 2, it's kind of the same idea. In step 1, you're just going to want to set it up, denotate your x and your v. In step 2, you're going to decompose it, break it down. In step 3, you're just going to connect it. And in step 4, you're going to substitute and simplify, and step 5 should give you the answer. Okay, so now we're just going to be solving trig equations. We're going to use double angle trig. We're going to prove 2 equations equal each other. You're going to combine the like terms, divide them by 3, and then you're just going to locate their corresponding inverses, and that should give you your final solution. And this is done by Ethan and Matei. So then for quadratic trig, this can be factored using the sum product pattern, giving you 2 possible solutions, which you'll see A can possibly be sine x equals 1, x equals sine negative 1, 1, which equals 90 degrees. And then b, you'll just have 2 cos x plus 1 equals 0. And cos x equals a half. So there you go.